Hello everyone. You are welcome to the week 4 of the Cairo Bootcamp 5. It's really nice that you're here this week again. So this week it will be all about Dojo building on-chain games. Yes. So if you're interested in building on-chain games, especially for your projects, you're in the right place. Yeah. So I think I'll just be handing over to Manoah. So at the end of the session, maybe we take questions and also know if you all have registered for the hackathon and how we proceed from there. Yeah. So Manoah, please you can take over. Thank you.
All right. Hello, everyone. How are we doing today? So let me see your emojis if you are doing good and you are ready for the class. Cool. John Bosco, Ebuka, Peter, June, Chinonso. Nice to have you guys around. So let me just share my screen and let's get started. All right. Can you all see my screen? Cool. So welcome to the week 4 of Cairo Bootcamp 5 by Starknet Africa. And in this week, we are going to be building on-chain games with the Dojo Engine. An essential one, we are going to be introducing ourselves to the Dojo framework itself. So for the past few weeks, you guys have been getting yourself familiar with the Starknet ecosystem, and you have been building on L2s. I'm sure most of you have been building on layer 1, maybe Ethereum, deploying your smart contracts to Sequoia before you made it thus far. So those are the massive amount of students we've been getting for the bootcamp. And I believe you guys are the same. So, and then for the past few weeks, you have been deploying smart contracts and getting familiar with the Starknet ecosystem, which is an L2 built on Ethereum. So today we are going to start discussing about another interesting aspect of building on the Starknet ecosystem. But this time around, you are no longer building on an L2, you are going to be building on an L3. L3 in the sense that Dojo is built on Starknet. Starknet is built on Ethereum. Dojo is built on Starknet, which makes it an L3 for scalability and mostly for game engines. So this allows games to be very fast. You guys will agree with me that building games on normal smart contracts usually have UX problems. So many a times games want data like really fast, and the blockchain takes a fractionable amount of time for it to process transactions, and then the type of calls we also make to be able to get those the state of the blockchain. So all those small times are usually compiled into large amount of times, which make games to lag, and then users don't normally enjoy the user experience. But this week we are going to be talking about the Dojo game engine, which makes everything seamless and much more faster. We are going to see the tools that were used to make this possible, and also explore the framework, how we can be able to build our own on-chain games with Dojo. So let's get to it. Who's pumped? Let me see your emojis. All right. So this is me. My name is Manoah.dev. I'm a blockchain developer and I've been building on the Starknet ecosystem for quite a while. You can check me up on Twitter if you like to yap and if you want us to connect. And on today's agenda, we are going to be discussing our 5 major things, which is to understand what Dojo is before we even start building, because that's the characteristics of every good developer. You have to know the tool you want to use before you are able to use it, right? And then understand the tool chain, the core tools behind Dojo, the framework, which is a new concept some of you are going to be learning today, but an old concept that has always exists, which is ECS. We'll know what that is shortly. Then the world contracts, which is a special type of contract, unlike the ones you guys have been written for the past few weeks, but somewhat very much similar and the same with the smart contracts, Then we are going to try to put all these 4 things together on how it all works. And probably if we have a lot of time still left, we are going to try to spin up an example project to look at the anatomy of a dojo project. But if we don't have enough time for that, we will do it in the next session before we get to building. So the next session is mostly going to be about building, but this one is going to be a bunch of theories, trying to understand our way around. So let's get to it. What is dojo? Let me bring this down. Okay, so Dojo is a modern framework for building provable applications in Cairo. It helps developers create anything simple from anything at all. Think of it like any simple NFT apps to complex on-chain games that probably before were not able to be run on the blockchain. Without worrying about complicated contract setups, indexers for or other querying systems. And then Dojo allows builders to focus on building only, building faster and more easily, which is what is more important, right? So many a times, you guys understand that Dojo programs are provable programs, or Cairo programs are provable programs. That's what you have been learning for the past few weeks. That is to say, when you run a program on Cairo, it does not just run the computation, but also generates a proof to be sure that that computation is correct and it's really happened. So the same thing with Dojo. Dojo is just a faster layer that allows us to run this same type of contracts or this same type of programs on the Dojo engine. But at the end of the day, everything is settled down on the L2, which is Starknet, right? All right. So what are some of these tools that make building much easier? So let's look at the tool chains. There are 3 core tools that allow us to build on Dojo much fast. Some of these tools, you guys are already familiar with them, and some of them are going to be completely new to you guys. One of those familiar tools are Katana. So I'm sure you guys must have seen Katana in the documentations or probably know Katana if you have tried to deploy on Starknet DevNet. So Katana is a fast local Starknet sequencer. Think of this as a local version of the blockchain that you can be able to run on your device. It does instant block production, so there's no need for you waiting for miners, which makes everything super fast. And unlike the regular blockchain, you have pre-funded accounts, which you do not need faucets at all. So you normally have pre-funded accounts like about 10,000 tokens that are going to help you for your gas. There are also wallets or accounts already generated for you with their public and private keys, which can be able to help you to make transactions. And also on Katana, you can deploy and run contracts. So think of this like Anvil. For those of you that have been building on Ethereum, think of this like Anvil, just a local version of the Starknet sequencer. So that's what Katana is. And it's mostly for app game builders or app chain builders. But it can also be for you as smart contract developers. But right now, you're a game builder for making it thus far and for attending this class. All right, so Katana is normally run on your local device and is run on ports 50/50. So you can be able to access everything you need from there. So we are going to try to run a local version of the blockchain here on our device later on in the class. With Katana, you can also fork the version of another state of a blockchain. Maybe let's say like the testnet state. You can fork it on DevNet, or the mainnet state. You can be able to fork it on Katana. So with this, you are able to test functions using the mainnet state, but on a local environment. So you understand what super magic that is to a developer. So the next tool is Sozo. Some of the names are funny, right? But they are quite interesting. Sozo is an all-in-one command line tool. This is CLI tool that you can use for Dojo development. Think of this like your cargo. Think of this like Scab that can able to help you in Dojo development. It handles everything for us, from creating new projects to deploying our worlds. If I say world, just consider world as your smart contract when I say world. So it helps us in deploying our world, and it also helps us in interacting with our deployed smart contract. So that's what Sozo is. It does all the heavy lifting for a developer who wants to build on Dojo. So how does it make that possible? You can create projects with Sozo init, or build contracts with Sozo build to be able to compile the bytecode or Sierra or Kazim code. You can also deploy worlds with Dojo migrate, or make smart contract calls to your world using Sozo execute, then the name of the method you want to call. And you can also query blockchain states using Sozo call. So with Sozo call, you can be able to read from the blockchain, all from your CLI, without you having to be on I said this Etherscan, being on any explorer. Then lastly, it can also help you to manage your permissions to write to systems or to read from systems with Sozo auth. So shortly, we are going to try some of these functions on the CLI. And you guys are also going to be doing this before the next class, where we build everything together. All right. So another interesting tool, and the last one, is Tori. So Tori is the guy that does most of the dirty jobs. Tori is an indexing bridge between the blockchain and the game clients. So you all know that blockchain data are not stored like properly, like they are all stored scattered in different nodes, in different blocks, different transactions, and what have you. So with Tori helps us index our data. When we say indexing, we mean having proper arrangement of our data on the blockchain so that we can be able to query them easily. This is what makes Dojo very, very fast, Tori, because it easily index events, and then those events are seen fastly by the user on the front end using SQL calls or GraphQL calls. So think of Tori as the graph. For those of you who have been building on Ethereum, or I think almost in every ecosystem, the graph has an integration for it. So think of this as the graph, but for Dojo ECS. So that's what Tori is. Tori is also a real-time indexer, like I've explained. So behind the scene, what it does is that it watches the blockchain. It indexes ECS data. When I say ECS, I mean entity component systems, which is the system in which Dojo is being built. So we are going to be explaining that shortly when we get to framework. And then this data is being served to the user on the client side. That's what happens under the hood. So it is built in Rust, which makes its performance super fast and makes it reliable also. And it also runs on default on the local environment port 8080. So after all your blockchain data are being indexed, you can be able to access them on this port. And basically, that's just Dojo. So one very nice thing about Tori is that you can be able to query blockchain data in different query languages. Like you can use GraphQL, you can use gRPC calls, and you can also use normal SQL APIs. Because what happens is Tori indexes the blockchain data, it gets data from the blockchain, persists them in an SQLi block database so that you can be able to have them in a indexed format. Then it automatically exposes an API that you can be able to use to query and then get this blockchain data that was stored in this persistent database. So while building on Dojo, you have to use events. So virtually everything, the state of the blockchain is being, or the state of your game is being managed in events. For those of you who have built on with the graph, you will understand that the graph gets indexed events. It doesn't keep it can't check the blockchain state, but it can be able to get the events that your functions is emitting. That's the same thing with Tori. That's what it does. But Tori helps us to also get other events. Like there are native events that are tied to Dojo itself, which helps in maybe emitting functions when systems are being deployed, models are created, new entities are called, and stuffs like that. So that's just what Tori does for us. So these are the three essential tools that you need to be able to start building on Dojo. And then they are super easy to install. So if you go to Dojo Get Started, you can be able to see the installation guide to be able to run all the necessary installation of these tools. I think there are three different ways. You can either install it directly from the binaries from GitHub using call, or you use Dojo Up to be able to install the all-in-one toolchain, or you use ASDF, which is going to help you to like manage your Dojo versions easily. I strongly recommend using that one because that's also what I work with. So with that, you can be able to update your Dojo versions, your Sozo versions in case of any recent updates. You don't have to clear and download again. So that's it for Tori, and that's it for the tool chains that we need. Cool. So now the framework, which is the second part of today. So the framework has to do with how Dojo was designed, how Dojo was made under the hood to be able to make it easy, how systems interact with models. Those are the framework. And then you guys will remember that I was mentioning or hammering on ECS, which is the system in which Dojo was built. So what's an ECS system, or what's ECS? ECS stands for Entity Component System, that describes a design approach which promotes code reusability by separating data from behavior. So this is not a system that exists only in Dojo. It's a system that exists in a lot of concepts, like in Unity game engine, for those of you who have tried it out, or in any of these, or in real game engines, they also use these same systems whereby they uh, separate data from behavior. So behavior, I mean the core logic of the that updates the data. So think of this as this. Normally in your smart contracts all exist in one place. Your storage exists in the same place together with the logic of your smart contracts. And then you can be able to make manipulations to this storage uh, directly from one system. But in Dojo, the models are different and are being set or deployed in their own different selectors, and the systems are also different. So this can make things modular, whereby you can easily add new systems. Or when I say system, I mean a smart contract. So you write systems which are the behavior that can be able to change this data, which in this case are the models. So instead of creating complex objects, everything is being bundled together. So you create entities which are things in your game. There could be anything that exists within your game, like the player. You can be able to, a player is a particular entity. And then you can be able to attach components to this entity. So components in this case are the data that are being joined with these entities. So like take for example, a player has an address that makes him an entity, and then a player can be able to have other data or other components like his life, how many lives the player still have remaining, or the current level that the player is in the game, or the status in which the player is currently playing the game, whether it's hard, easy, or stuff like that. So those are the different components being tied down to the entity. So an entity must be unique. We are going to look at that much more shortly. Then lastly, after you have the entity joined together with the data, you are going to have your systems. So your system is the logic that operates on the data that we are storing together with the entities. So look at your systems as where you write your core smart contract logic, where you write your read calls, where you write your write calls to be able to write to the Dojo system. So basically that's just it about the entity component system. And then this system is what makes building normal Cairo smart contracts or Cairo dApps with building Dojo dApps completely different. Because smart contracts or Dojo or Cairo contracts don't work with entity component system, but Dojo contracts introduce this. So under the hood, what are these entities? So let's know what they work. I've been speaking a lot of English. Let's look at them. So entities are unique identifiers for things. I said things refer to anything that lives within our game, right? For things within our game, they can be players, items, or anything at all, depending on what type of game you are building. Because Dojo, you can build a very simple game as a snake game on Dojo, and you can be able to build much more complex games as COD and GTA and the rest of them live on Dojo. So any variant in a model that has a key attribute is an entity. So we are going to be introducing models shortly, but in every model, you are going to notice this. This is an attribute. For those of you new to Rust and Cairo, this particular key is an attribute that defines what this variant player is inside of our model. So example, a player with an address of OX01234 is referred to as an entity. So that's what an entity is. Like I said, it can be anything like the simple English definition. So next, we have the models. So models, another word for them are components. These are key value stored components within our Dojo systems. So models are the same thing as your Cairo structs that represents game data. They are annotated with this procedural macro, which is Dojo model. They have the same macros as Cairo struct, but you have to add this particular macro to make the compiler know that this is a Dojo model. We're going to see that shortly. Then they are stored automatically in the world contract. So I talked about the world, right, which is a special type of contract. We'll see that shortly, but the models are stored inside of the world contract. And the world contract is the general contract that users can be able to um, interact with or call the logic to be able to make state changes. So we store these models inside of the world contract. And then the models are also queryable via the Tori indexer. So for any model that you create, for any of these structs that has an entity with a component, you can be able to query it with the Tori indexer at the end of the day when um, your world is being deployed. So that's it about models. So understanding models much more better. As you can see, this is a simple example of a model. Public struct position. It looks exactly as a Cairo struct. And you can see the standard Cairo traits that it implements, which is the drive traits that allows the copying, the dropping, and also the serialization of this particular um, data type or this position data. So the name of this model now is position. So for those of you who are backend developers, you already know what models are. They are the same models that you use for your schemas in backend. It's the same logic, it's the same concept that they are also applying here. So think of it that way. Uh, then you can see the famous attribute I talked about, this annotation, which is the Dojo model, that tells the Dojo compiler that this is a Dojo model. So with this, when it sees this annotation, it's going to allow Tori to be able to query this or index this particular data. Then every model must have a key. Every model must have a key entity in it. So every model must have an entity and a component. Just know that. Like in this case, this is the position model that states the position of a particular player in a game. And then the key to be able to get a player's position is the player's contract address. So this is the entity identifier or the key I introduced much earlier. Then these are the model data or the component X and Y. So let's say the player is in X direction or is in Y direction, which is going to be what we are going to represent on our front end to know where we are going to display our character and stuff like that. So the data fields are actual component data like X and Y. So that's basically it about models. And this is what they look like. So don't be scared. It's the same Cairo that you are writing that you are still writing this time around. But the thing is, you are just using much more, you are just in a much faster environment that makes building games sweeter. Okay, then to the master of it all in the framework is the systems. So like I said, the system is your smart contract. So in Dojo, you can have as many systems as possible. So like I said, it is separated in an entity component system. So everything is being modularized. The logic for updating your game is written different. The logic for updating player states or for updating user details to know about the player details and stuffs like that can be kept different so that when you want to change your game logic is easier for you, and when you want to change
No, no, no.
your
I love you. Yeah, yeah, yeah. Take
somebody's
it.
having fun.
Smile,
Javed,
smile.
Gege, how do I mute this guy?
I've done that already. Thank you.
Okay, I never knew we had Gege fans here. That's interesting. Uh, okay, so I was talking about the systems, right? So they are just like your smart contracts in a component format that you can be able to, and then at the end of the day, these systems help us to change the models, and we know that the models are the data or the states variables of our systems. So with the system, we can be able to update. You know, in the blockchain, you can only perform two transactions, two stuffs, which are reading and writing, right? It's either you are reading from the blockchain or you are writing to the blockchain to make state changes. So the system is what makes that possible. With systems, you can be able to write functions that can be able to read. And with systems, you can be able to write functions that can be able to manipulate your game states and emit events for the Tory indexer to index, and then you are going to get it on your client side. So that's just the concept, and that's how it works. So they define how data changes in our world. Uh, and then they are the same Cairo contracts that you know. So let's look at a simple example. This is a simple example of a system workflow. So you can see you also have the same interface that you know implemented from Starknet interface, iActions. But instead of writing Starknet contract, you are going to make the compiler know that this is a Dojo contract. You write the same stuffs. It has these different functions in them. Then you can be able to update the model and read from there. So in the system workflow, the first thing you do is to get your world dispatcher. So you can get the world here, which is going to give you access to your states that are going to start manipulating. So, you know, normally when we want to build on our smart contract, we just define a storage in here, and then we say self dots. Then we point to storage, the item we want. Then we write dot write, and then we write to it, or we write dot read, and then we read from it. But this time around, when you get your world dispatcher, there are two helper functions that also help us within this case. First is the read model. So with that, you can be able to read any of the models because you know we are storing stuffs in an entity component system. So we can have as plenty models as possible. So you can be able to tell the system, this is the particular model I want you to make changes to. I want you to make changes to the player model, or I want you to make changes to the game model. So that's just how it works. And then the contract also help us to validate inputs, which is what we collect for writing to our functions, and also check for preconditions like assertions. Who is making the call? Is the person allowed to make the call? And stuff like that. Just the regular stuff you do as a smart contract developer. That's the same job you still have here while building on Dojo. So it's the same job description, just that you are building with entity component systems. So, like I said, this is where the game logic apply. This is where you apply the business logic, whatsoever you want. If it's a snake game, okay, this is where you tell the user, move up. This is where you say, when a user hits this particular apple, add its length. This is where you say, when a user hits the wall, end the game, and stuff like that. Then the second function we have access to within the word dispatcher is the write function, the write model function, which points to a model, and then we can be able to insert new data into the model. Then events, which are being emitted automatically. These are events that are being called when a user make particular calls, or you could create your own custom events. Custom events are the same events that you still know in Cairo. Those same events, those are what you are also going to create, and then you can be able to emit them inside of your system. And then Tori is going to get this index data, and then you are going to be able to use it on the front end. Mind you, when building on Dojo, you are not going to be reading the same way you read in your front end using RPC calls. No, you are going to be reading in like better ways now, like GraphQL, SQL APIs, and the rest of them. And then this data, these stuffs, they work with an indexer. Before it gives you access to this data, it doesn't go to the blockchain direct. It goes to a database storage that still has the same data that exists in the blockchain, so that you can be able to query it as fast as possible. And then this indexing, there are certain things they work with, like your events. So if you don't define your events within your smart contracts or within your systems, the Tori indexer is not going to be able to index it. And then with that, you are not going to see that data within your front end. So you have to be careful when building this time around, and events are very important. For those of you who have been building with subgraph, the graph, this is not a new concept to you. You are completely familiar with this. All right, so that's just it for system workflows. So to another interesting guy, the world contract. So I've talked about models, I've talked about systems, and then I told you all of them can live in their own separate entities, right? But the world contract now is the guy that amalgamates everything. Is the guy that joins everything together. So this is the central registry for everything. Everything is being registered here, the models, the systems. And then when you want to make a call to a particular system, you have to go through the world, which is going to give you access to that system if you have a permission. So the world contract manages permissions. And also, if you want to read from your models, you can be able to get this information from the world contract. So the world contract is what is being deployed at the end of the day when you run Sozo migrate, which is one of the methods I explained earlier that you can use to migrate. When I say migrate, it's the process of deploying your smart contracts on the Dojo toolchain. So I haven't gone really deep to try to understand how Dojo really works under the hood, how they are able to manage this world contract and makes it a central registry. But in my head, I'm looking at as they use the concept of upgradable smart contract to be able to implement this logic. And then every system is its own separate component. And then with that, anytime you make changes and you run Sozo migrate, it is going to get the current update and is going to upgrade the current world smart contract for you. So I think behind the scene, that was what they use. But I urge you guys to go deep, to want to study and understand how it works, because if you do that, it makes your building much more easier because you understand the tool better. So in a nutshell, the world contract coordinates models and systems. So that's what it just does at the end of the day. It coordinates all the models and all the systems. So shortly, we are going to try to run the Dojo 101, which is the first introductory to Dojo that is going to allow us to know all the necessary things we need to know for building in the Dojo ecosystem. So this is just a theoretical aspect. We are going to try to look at the anatomy of a Dojo project. So we look at it within our IDE, and we understand much more better as developers, which is the language we understand, other than too much theory. Let's get to doing. But we're not going to be doing a lot of doing today because the next class is going to be much of hands-on. So this class, we're just going to be doing a lot of introduction. Then you guys are going to try to deploy. I said deploy. You are going to try to install all the necessary things you might need before the next class so that we get ready to doing the real thing. But this class is just an introduction. Okay, so how do things work all together? So all together as developers, we write models, which is the data, the container where all our data are being stored. And then we write systems, which is the logic that can be able to change the data, all in Cairo. Then we run the local Katana blockchain. Mind you, using Katana, you only do it when you are on the local environments. When it's time for you to start building the real stuff, like building on the test net or mainnet, you are going to deploy directly to the normal Sepolia and mainnets that you know. And I'm going to teach you how to do that in the next class using Sozo. So it's super easy. And then you are going to get the world deployed on Sepolia or mainnet. Then you try to interact with it on your front end. But for now, for starters, we are going to be using Katana, which is a local blockchain. So after we've written all our logic, we deploy it on Katana using Sozo, deploy it, and then we get our world. Then we use Tori to index our world. And then what Tori does is that Tori is a watchman. Tori just watches the blockchain. That's just his work. He just stays morning till night, waiting for we to be able to make calls on our systems or on our world. Once changes are made on our world, Tori picks those changes, puts them in the persistent database, and then put them in a queryable format that we can be able to read and view on our client side. So with all of these 4 steps, the client can be able to connect with the cartridge controller and play our games on Dojo that we have just deployed. So that was a lot of talking. So let me see your emojis if you were with me or if my mic was mute. Then I start crying. Cool, Ebuka. So we only have one person in the class. All right. Ajibode, I see you. Ramat. All right, so let me just jump out to get water for a sec. Then as soon as I come back, we are going to run Dojo 101. So for those of you who have gone through the higher institution, you know what 101 means. That is the ultimate starter for everybody who is just starting out. So this is for anybody. And when I mean anybody, I mean anybody at all. Even though you have not been part of the bootcamp from the get-go and you are here now, this class is for you because this is an L3 that we are building on now. But if you're an absolute beginner to programming, this class is not for you, please. So we'll be back and then we try out Dojo 101. With Dojo 101, we will build our first Dojo models, systems, see the anatomy and how they work. So just hang on for me for a sec.
Hi guys, how is the session going so far? Are we following? Okay, great, great. Oh, nice. So in the meantime, I'm going to be sharing Telegram link for us to join. So we created a Telegram channel for the just to keep track of everyone's project for the hackathon. So I just sent the link to the Telegram group in the chat box. Please join. We'd also share it via email for people who are not on the call. Okay, I see two people have joined already. Okay, three.
So I have a question, sorry.
Okay, what's your question?
Um, what is that question again? Um, like so currently now classes are on and we are preparing for the hackathon. And
Mm,
I want to like ask like next week, upper week, are we still going to have like classes or is it just more of introductory to Dojo and how to use Dojo? Is that what we'll be having subsequently?
okay, so next week is going to be the last week for class. Let me open to just to ensure that I'm saying the right thing. Where's the Notion page? Bootcamp curriculum. We just have 5 weeks. Yes, 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 yes. Next week is the last week for class, and next week class is all about just Cairo security and testing. So would say the main thing for you to like start building your project is actually this week. So next week is just for Cairo testing, Cairo security and testing. That's all. Then you can, and would not be giving you assignments from this week going forward. So you only have assignment from week 1 to week 3. Yeah, is that okay? Did I answer your question?
Yeah, you did.
Okay, so please join the join the channel. Thank you. Please, you can take
I've joined the channel.
okay.
All right, guys, can we proceed? Is my mic mute? All right. So can you guys see my terminal?
No, I can't see on my end.
Are you still seeing my?
I'm still seeing the slide.
Oh, okay. So let me switch what I'm sharing. Okay. This should allow you to see my whole screen, right?
I think I'm seeing your terminal now. Learning mano.dev at mano.dev.
Are you thinking or are you seeing it? You
I'm, I
guys
think I'm,
seeing it?
I think I'm seeing your
Yeah,
terminal.
we're seeing the terminal.
All right, cool. Okay, so let's get to it. So this is my learning folder for learning new things. And today we are going to be learning Dojo together as devs. So your first go-to location is the Dojo official documentation. Head over to get started. Start reading everything as much as possible for you to read. The documentation is always the best place to get started with in every ecosystem, because that's where every problem is being solved, and then the real examples are being displayed there for absolute beginners. An explanation of a lot of concepts are being done there. So look at your documentation as your Bibles or Quran. So that's the best place to get started. So remember, I talked about the different tools you need. So those tools, you first have to deploy all of them. Escape. Good. Now let me just go here. Yeah. My network is slow. But I'm glad it's not affecting the class. Oh, okay. So you head over to the get started. We understand what Dojo is much more properly, more than how I explained it for you guys. Then you head over to the installation guide on how to install all the necessary things you need to start building on Dojo. We're not going to be doing that in this class because I already have it installed. And if I take a pause and ask you guys to do this, it's going to take us like ages, because we are going to realize some people's devices uh, cannot are going to come with their own funny errors and stuff like that. So I will advise you take the whole of this night or the whole of tomorrow, if possible this night, to run all the necessary installations and make sure that you have the latest version of Dojo running. So I, for one, I don't have the latest version currently, and though I've been building, everything is working fine, but there's a particular deployment I want to do tonight, which warrants me to deploy to the latest version. So I'm going to be doing my own upgrade today also. So you guys should do that. So we are going to be in the same pace. And then when we meet in the next class, when we are building, you guys can be able to code along with me, because we are going to be build a very simple game, as simple as possible. And God's willing, get it integrated from the back end, which is the contracts or the world, to the client side, and then we can be able to try it out, no matter how simple. Yeah. So you head over to the installation. You can see you use either call to install or use the ASDF method that I talked about. Katana, Dojo, there are different codes, all are here. With ASDF, this is the command to run. After adding the plugin, you run install Sozo, Katana, and Tori, which are the three different tools, right? Install the latest versions. Or if you want to install a specific version, you do it this way. If you want to list all the available versions, you click this, then you see all the versions all within your terminal. So ASDF is, think of it like homebrew that helps you download and manage packages or tools. So you could, if you are using an older version like me, you can be able to update and set to a new version. This is what I'm going to be doing, both globally and also in the home. Or you could use the Dojo app, which is an all-in-one tool chain that has Katana, Tori, and Sozo all inside. and then you run the call to be able to install it. You run Dojo up install. If you want to install with a normal version, you use or a specific version, you write the name of the version. And then you are going to get the same thing as installed by ASDF. So to verify that everything is being installed, you check out using sozo dash version. You are going to see the current version. Also check out your Katana version. I'm sure most of you must have Katana installed already. Then you can also check out your Tori version to know what you are working with. Then to test your installation, you can be able to clone this Dojo starter project and then run the build to be able to build the project. If everything goes successfully without any errors, you know that all is being installed and you are good to go. So these are also different methods to use to troubleshoot. But for now, we haven't run into any problem, so there will be no need troubleshooting. So let's save ourselves the stress. But I'm 100% sure in the next class, it's going to be a lot of troubleshooting up and down. But it's actually not hard. It's super easy. So it's something that we can do. And then as a developer, just know that the more problems you go into or the more problems you encounter, it makes you a better developer. So with that, you face more errors and you can be able to fix them in faster periods than you were able to before. So this is just the documentation. You can read as much as possible if you're a good reader. If you are not a good reader like me, you don't like reading, you can go in and just deploy all the necessary stuff and start breaking things. Then you learn the hard way. Either ways, they are all parts of learning Dojo. But the best location to get started is where we are now. So Dojo 101. So before we get to Dojo 101, you can also check your first Dojo app. So with this, you are going to run a Dojo app from end to end, front end, back, and the contract using this tutorial. So it's going to open your understanding to how everything works much better. So Dojo 101, which is the tutorial that helps us to initializing our new Dojo project, writing models and systems, deploying our first world, and indexing the world with the Tori indexer. And also, we are going to try to execute calls from Katana and try to query the state of Katana to see the state changes that we have made. So that's what we are going to be doing in the next few minutes before we end the class. So the class is already coming to an end. So if you are not familiar with this, what is this? There's a warning here. So an info. This session assumes that you have already installed Dojo toolchain. Good. So don't go and start using it without installing. And you are familiar with Cairo. So for those of you who were in the class for the past few weeks, for you. If not, please refer to the installation to install or go back to the Cairo book and spend 1 to 2 weeks doing Cairo. So we'll do this in less than 15 minutes and end the class. So the first thing we'll start is to create a new project, which we do almost every single time. With JavaScript, we do, with React, we do create React app. With Cargo, we do Cargo new. With Scab, we do Scab init. Then with Sozo, we do Sozo init and the name of our project to be able to scaffold a new project to get started with. So with this, let's run this now. Where's my terminal? Cool. So in the learning directory, I'm going to paste Sozo init, then the name of our directory, the name of our project. So this can be anything. If the name of your project is Ebuka Moses, you just say Sozo init Ebuka Moses or whatsoever the project name is. So you click on enter. if you have Sozo and everything installed, it's starting the project, and then it's trying to find a template. Cool. So it has successfully created a new Dojo project for us and has done the setup complete. So to start using it, we are going to check out into the new project and run Sozo build. So ls to view. Oh my God, I have a lot of stuff here. So what's the name? The name of our project is Dojo Starter, right? Dojo Starter. Yeah, so this is it. This one. So let me open it with VS Code. I will just say code Dojo Starter. And then we are going to have this opened. All right. So can you see my IDE? Emojis if you can see my IDE with a Dojo Starter project opened. All right, cool. So this is it. This is what a Dojo project looks like. And the different stuff. So we are going to be looking at this shortly. Some of them are familiar, some are completely new. And then this is the anatomy of a simple Dojo project and all we need to know. So first we have the scarp.toml. I'm sure all of you are familiar with this. This is where all our configuration for our project lives. We have the dojo dev.toml. This is where all our dojo dev configuration lives. We have dojo release.toml. I haven't gotten deep to understand what this is. Then we have our source folder that contains all the source code of our project. The lib, which is the entry file, the models, which contain the model of all our states of our game. Then the systems. Under the systems, we have actions, which contains all the logic that manipulates our models. Then finally, the test folder or the test folder that contains the test file that we can use to be able to test our systems before deploying. All right, so back here, let's look at the main stuff. Aside VS Code, aside this guy, let's start with SRC, which is the source directly. Look at lib.cairo. It exposes all the necessary stuffs we need. Let's check out our models. So these are the models that we have for our game. As you can see, this is one very good example. To know that this is a model, how do I know? It is annotated with the Dojo model attributes. And it also has the Cairo standard to help for dropping, copying, printing, and also serializing. So how do I also know this is a model? I can see it has a key. So the name of this model is moves. So this is the moves of the player in the game because this is the key or the entity of this particular model. Then these are data that exists inside of this model. I have the moves, that is how many moves is remaining for this player. I have the last direction. What was the last direction that the player followed? Then I also have the can move boolean to check if the user is allowed to move inside the game or not. There are also other models like the directions available. It has a key, which is player. So you can use the player to check all the directions that the player is allowed to follow within the game. This is also the position to check the player's position. So you can see all of these have one thing in common. They are structs. They are covered with, they have this model annotated to them. They have a key and then a component to store the data. So that's just simply how a model looks like. So these are all the examples of a model. Though some here are not models. Like take, for example, this enum, because it doesn't have a model in it. And it's supposed to be a struct. So, this is not a model. So these are the ones that are models. All right. So that's how a model looks like. And then notice one thing, models are being made concise and simple. They store as much information that are supposed to be needed in the particular component. Like look at this position. The only thing that needed to be stored here was a vector. And then it has a key of a player. So you just pass the player and then you get the vector. So that's just it. So as a backend developer, you know that we do the same thing in maybe Node.js or Rust. We create a model folder. In that model folder, we define what the data looks like, what is going to be accepting, what we are going to be saving, the data type that we are going to be accepting, and what have you, just to model how the data is going to be stored in the database. So that's the same thing here that we are doing. So enough of these models. Now let's check out systems. So system is this guy that makes changes to the models. So you see we imported models here so that we can be able to make changes to them. Systems can be able to expose public functions, which are functions that users can be able to interact with. Like within our game, we can perform specific actions like spawning, like making a move. To make a move, we pass the direction to be able to know what direction we want to go. Like let's say it's a snake game. Do you want to go up or down? So we pass in the move and then we make that particular call to using the system. And then, like I said, the system allows make read calls and write calls to the models. So this is what we are going to be noticing here. So you can see this is a simple event before we get to that. No. So before we check event, let's look at this. So this is the implementation of our traits, of our action. The same thing we do in Cairo contracts, right? You can see it's also annotated with the embedded, with the ABI embed V0, which helps us to generate an ABI for these particular functions. So this is the spawn function. So the spawn function is the logic that is going to help us make spawn changes. So let's look at it. So as you can see, first we get the world dispatcher to be able to read and write from it. We perform the get call to get who is going to be the caller. The using get caller address. As a Cairo dev, you are not new to this. This is an old concept to you. Then we can also read from the model. So this is the world that we got. We can, to be able to read from a particular model, we call world.read model. Then what is the model that we want to read? We pass in the model from the one that we shaped. So I want to read the player model. So if the position is what we are trying to read. So you see the two models we pass here. So we are telling it, I'm trying to read a model, and then I'm passing a key. So if I pass in a player, which is a contract address, get me the position of this particular player. So that's just what's happening here. So with this, we can read the state that is being stored in the world. Then we can be able to make changes, which is what is happening here. We are trying to make changes to the player, like in the position struct, we are remodeling it, passing back the player, then passing the new position that we want to put the player. So we are going position X plus 10 and position Y plus 10. This is probably trying to make the player much more bigger. And then after we model this, we now write to this particular model. So we can write using world.write model. Then we pass in the new changes that we have been able to make to this model that we read. So that's just it, as simple as that. Then we can also set the player moves, change the moves. then write the moves for the changes at the end of the day. So this is a simple function. Then next, we can also check out move. We also read, make ordinary moves. We check if the user is allowed to move or not. We check the last direction, model the next move, then we write. And then at the end, we emit a custom event to show that the player has successfully moved to a new direction. So this is the event that we have here, which is the moved event. So the moved event, like your normal events that we have in Cairo, it has a key which points to that particular event, and then it has the direction. That is, when a player is moved, we pass the player's contract address and also the direction in which the player moves, so that Tori can be able to index, and then the front end is going to know where to place the player currently. So that's exactly just what's happening. For those of you who are Cairo developers already for the past few weeks, you will agree with me that this is not a new concept. This is what we are very much familiar with. So lastly, we can also have private functions, which we get using the generate trait. These are internal functions. So one of the internal functions is the function that helps us to get the world state or the world dispatcher. So this is it. So we call self, then we try to access the world storage that exists on that Dojo world. Then we call self.world, then we read the particular world using the namespace. So every world has its own namespace, and then all the namespace are being saved inside of the scarp.toml. When we get to the scarp.toml, you guys are going to understand how this works better. Then these are just helper functions that helps us to run, know what's the next position to take the player. So that's a simple example of a system and a model. So as you can see, we write all the models here. Then the system, the model are imported here, then they are being changed. Read or write, all is being performed inside of the system. As simple as possible. Next, we have the test folder, which shows us all the test files. Here we can be able to test the functionalities of our world. It's the same way that we do it in Cairo. We write our test in this way. But the only difference is, instead of we deploying and declaring the contract, we just try to get the namespace. And then from the build class hash, we can be able to get the models, the events, the contracts to be able to make the calls right within our test environment. So as you can see, it's the same way that we do our regular test in Starknet, right? There are sessions and the rest of them. Just that here, I can't see the Foundry functions like starting pranks, stopping pranks, and stuff like that. So we'll not say they're entirely the same, but they look exactly alike. Okay, so that's it for test. Then finally, we have the lib, which is the entry file that exposes everything. So we are making the system public. What are the systems we have within here? We have the actions, so that when we are trying to migrate, it's going to know all the codes that are going to be migrated for us. Then all the models, and finally the test. So that is just it for the source folder. Is where the logic or the models exist. So let's have a look at our scarp.toml. So our scarp.toml is where all the necessary project configuration exists. This is a very delicate place. You have to be very careful, else you make lots of mistake. This place shows us, is generated for us while we run the init. We see the necessary package, like the name of our particular project, Dojo Starter, what version we are working with, the edition. We can see all the different scripts that we can run to migrate, spawn, or move. the different dependencies that we have within this project, like the Dojo and also the Starknet dependency. We can also see the target Starknet contract. I don't know what this is. I haven't explored it. Then it also allows us use the Dojo Cairo macros. So we can be able to use all Dojo macros within our project. We also have normal dev dependencies like the Cairo test and the Dojo Cairo test, which helps us in testing. So that's just what the scap.tommy looks like. There are other stuffs you could add, like the profile when it's time to deploy. So you can be able to specify the different profiles here because on DevNet, we have pre-funded accounts, right? Which is being given to us by, what's the name of this stuff? By Katana. But on DevNet, on testnet or mainnet, we have to use real funds or use testnet funds. So with that, we have to connect our private keys to accounts that are real Starknet accounts, right? So with that, all the configurations can be done from the dojo.toml, and then everything is going to be exposed inside of the scap.toml. So this takes us to the dojo.dev.toml. Mind you, when you are deploying on Dojo, you have to know that every environment has its own configuration to get deployed. Like to deploy on DevNet, there are stuffs you need. To deploy on mainnet, there are certain configurations you have to do. But they are essentially the same thing. Like in the dev, you can see all the description of our world, like the name of the world, Dojo starter, the description, the cover image icon, the website, the seed. You could change all of these. So the seed is a unique stuff that helps when deploying to know if this is a newer version of stuff you are deploying or you have already deployed the particular version. The different socials of your project, then the namespace, which is what I'm talking about. So the namespace is how what your Dojo world is going to be referred to as Dojo Starter. So depending on what the name of your game is, that can be the name of your namespace. Then you can also set up your env variables here. I said we are working with private keys, public keys, right? So we don't you are going to run script that from that script is going to read the env files, then perform the deployment and stuff. So we are going to see that in the next class, not in this one. Writers. So the writers are the systems are given permission to make changes to the contract. So like in this case, the Dojo starter is allowed to make changes to the Dojo starter actions. So all of the action systems are allowed to be changed by this particular guy. So this is the simple anatomy of a Dojo project. Forget all these other guys like the license. You guys can go and read more about them. Don't forget them actually. You guys can read about them. But I don't care to do that. And then you can also run Dojo in a Docker environment, which is in a container. I don't do that, but you can. Most people do that actually. Then the manifest. This man.
I think his network has kicked him out. We'll try to reach him. Mm.
cut off for a while. I just hope we were not lost for a long period of time. So you guys can remind me where I stopped or where you lost me. You can write it in the chat. Can you guys hear me? Okay, yeah, Docker, right? Why I said you could run it in a container environment. Cool. All right. So where did it even go? So which of the screens am I sharing? Okay, one. Okay, so you can see my screen now, right? Good. And I'm in the IDE.
No,
Can't see
your
your
screen
screen.
hasn't come up yet.
All right, let's just hang on a moment. But it stays here, you are screen sharing. How about now?
Still
Can't see
nothing.
anything.
All right, let me stop and start sharing again. It says I'm sharing.
No, I can't see anything from my end.
Are you sure I won't leave this call and join back?
I think that would be better.
All right.
So I noticed four persons have not joined the Telegram channel yet. If you have not joined the Telegram channel, kindly do so. Do so. It's important that everybody's on that channel. Let me send the link. Mm, not sure, Peter, you've joined yet. Also, Daniel. Who else is on this call that I can't find them in the group? You have, okay, yeah. Okay, I can see Greek. Thank you. Kola Wole, have you joined the Telegram channel? Are you with us? Akeem
I've joined
Smith.
already. I've joined.
Oh, okay. Akeem Smith.
Yeah, I've joined the Telegram group. I've joined the Telegram group.
Okay, I'm talking about for the hackathon, no, not the Starknet Africa Telegram channel.
Okay, I'll join now. I'll join now.
Yes, the link is in
Okay,
the chat box.
okay.
Uh, who else have I not seen on that group? I'm not sure Stanley has joined. Hmm. Every other person is there. All right. Wait.
So how about now, guys?
Yes, we can see it.
Cool. It says participants cannot see your screen. All right, makes sense. All right, so that's just it. So for a Sepolia environment, now this is the dojo For a Sepolia environment, you are going to have the dojo sepolia.toml. For the mainnet, you have the dojo main.toml. And then you set the relevant private keys, the accounts that are going to help you for your deployment. Mind you, for your DevNet is completely free because the accounts are pre-funded. But for testnet, you need a wallet that has up to 0.001 ETH, right? And STRK. So you need it. So don't go and use an account that doesn't have any sort of funds in it. It's not going to work out. Yeah, so that's just it. Most of the explanation I did today were for the smart contract or for the back-end Dojo contract and systems. So to integrate on the front end, we work with what is called Dojo JS. Same concept that we know with Starknet JS and or ITAS JS. So Dojo JS help us to integrate our Dojo systems after they have been indexed by Tori. So we can be able to get all with our entities, be able to get the events from our Dojo world. So there are also other tools that you can be able to use on the front end, not just Dojo JS. Paul. So there are also other tools, like not just Dojo JS. You have Dojo Unity for people who are using Unity, Dojo Unreal, Dojo Rust, Dojo Telegram, Dojo C, and the rest of them, right? Depending on what you are working with. But for this, since we are integrating with the front end, we are going to be using Dojo JS. So let's try to make some of these calls that we have been talking about since, like starting a local Katana development server. So you guys can go and do this in depth at home. I will just run an overview here. So you guys will just see how some of these things work. Because without you trying yourself, you are not going to be able to see. So the first thing you do in every project is before we can be able to interact with the state of the blockchain or get our Dojo world deployed, the first we have to do is to start up our Katana environment because we are in the development space now. So if you are not in the development space, let's say you have already finished building on dev, no need to use Katana. Direct, just deploy to Sepolia using deploy to mainnet. There's a in the Dojo documentation, there's a session that talks about that. So we have to start a Katana environment now. So to be able to start the Katana environment, you have the code you have to run. A very simple code. Or before we start the Katana environment, this is already built, right? Since we already have systems here and models, let's be sure everything is working. So the first thing I do here is to run sozo build. So with this, I'm going to build the project to be sure I don't have any errors in my preconditions or in my logic. So if this goes well, I'm sure we are good, right? So sozo build. What's it saying? Okay, this is an issue. All right. So just hold on a little, guys. I suspected this problem might come. So like I told you guys, I want to do an update this night for the project I'm working on. So the problem is I started doing the update and then I didn't finish it before the class. So I'm going to get some issues here. So what will happen is I'm going to switch some dependencies so that I will use the right version that my system is familiar with. So my system has 1.2.2. This should work. Or let me check something. Okay, 1.2.2 is working here. 0.2.2. Then my Cairo version is currently version 2.9. I think that was one of the errors it's saying. 2.9.2 also. So let me switch my Starknet version. This should solve the problem. All right, let's see. Okay, it's complaining about the test.
Miro, abure amanya mpaka kwa ule mkoi magizo umonte. Raso watria, ro bimendo triando bien.
Okay, so this problem entirely exists on the terminal file and how I initialize my Cairo project for starting that update. So in the scarp.log is also reading version 1.8. So this is the problem. Let me see whether tweaking this is gonna make it work. If it doesn't work, we could just try it out in a project I'm already working on that I spinned up with the version 1.2.2. That should work also. So I just made things worse. All right. So let's try this out with a project I'm already working on, since it's just the commands that we want to run. So the issue now is I have a conflicting version because I started making the updates. The current Starknet version I have running is version 2.9.2, and it is not compatible with the Dojo version I started installing, which is version 1.8.2. But I have a project that has the perfect implementation, which is this guy here, that we can be able to run. So let me just turn off all these processes. This is a project I'm currently building. It's a new implementation. All right. So same stuffs that same explanation. I have my systems, I have my models, I have my tests. Don't mind all the red that are showing. It's just a language server issue. There are no errors. So let's try to build this project now to be sure everything works well. So I call Sozo build. Same thing. All right, guys. So just hold a sec. Let me do something. I shouldn't have started this installation before the class. So I want to install a certain version. So let me check out the installation. So since I'm working with ASDF, let me just copy this code. And then I want to install a specific version. So let me go back to the original version I was using. 1.2.2, right? Before I do the update later. Okay. All right. So I already started this installation and things have already gone messy, to be honest with you guys. So the current time we have for this class is not going to take us to make this work out. So I'll have to continue the installation or do the necessary stuffs in the next class. Because obviously you can see here, compiler plugin could not be loaded. Dojo plugin version 2.92. So I'm using 1.2.2, but it can't work because it's expecting 1.8.0. And then if I try to use 1.8.0, 1.8.0 is not compatible with Cairo's version 2.9.2. So obviously that should give us an issue again. Let's see. Oh, what's happening? Can you just run the command? So the commands don't even want to run. That's serious. Could this be a network issue? Possibly. So today is not the best day for this. So I'm going to fix all my necessary dependencies and my tool chain, and then deploy my project so that in the next class, we are going to work with this much more in depth. So already this was supposed to just be an addition to what we are supposed to do in the next class. But since we ran into problems, we'll just continue doing it in the next class. So this is a more better reason for you to stick to the next session and make sure you are here so that we are going to continue building on Dojo together. So with this, I hope you enjoyed the session. And thank you very much for your time. So I'm going to pause now for questions. So I think we have about 9 minutes. 8 minutes now. So if there are none, I will advise you guys to immerse yourself in the Dojo documentation from now to the next 2 days, which is today and tomorrow. Then we are going to meet for the final session next tomorrow to be able to build a simple game with Dojo. So make sure you install the latest version. Everybody should have the latest version of Dojo, and we should be good to go. So thank you very much for your time. Sarah, I don't know if I'm free to go now.
Yeah, there's a question in the chat box.
Okay. chart? Where's the chart?
Have you seen it? Or I should read it out.
I can't seem to find the chatbot. So let me open this. Okay, yeah. So might there be a situation where we have more than one model Cairo file or action Cairo file? Yes, 100%. And in the project I'm working on currently, have I stopped sharing my screen?
No, you're still showing it.
Okay, cool. So let me just show you guys. So you can have multiple, like you can see now, I have a models folder and I have different models. So I'm building a game, and the game I have attempts. So you can see all the different attempts, how I modeled them. I have the daily game models. I have the game
So we
start
can't we
models. I
can't
have the
see
game.
we can't
These are for the classic game.
mm,
Should I have zoom?
okay, we can see it now.
Can you guys see better now?
Yes.
You can see now, right? Oh, I don't know if
Yes,
you
I
guys are
think
with
the
me.
network is lagging. We can see it.
Okay. So you can see all the different models I have here. I don't just have one. I have lots of them. Then you can see all the different systems, actions. I have my daily game systems. I have my player systems. I have my world. This is a library and the rest of them. And then depending on which model I want to make changes to, I import it into that particular system. Then I make my changes. Then I expose all of them in this lib. Then in the end of the day, when I run Sozo migrate, it's going to amalgamate all this stuff and then deploy it to one particular world. And all of them will have their separate selectors that we can be able to find with them. So if that answer your question, if it doesn't, I can explain more.
Okay, I think it's fine with the
All right, cool,
question,
Peter.
with the answer. Thank you so much. I don't know, guys. Do you have more questions before we end the call today? So, Manoah, I don't know, would Thursday 2 hours be enough for what you're going to cover on Thursday? Because you're going to like be building the game, connecting to smart social and all.
Yeah, so we just try to build something very, very simple. So 2 hours should be
Okay,
enough. If
okay,
we all come early, so we start as fast as possible.
okay, great then. All right, I think you can stop sharing your screen now. Thank you. So, guys, any other question?
All right.
Questions for the class, for your tutor, questions aside from today's class. Um, if there are none, so I think we'll call it a day. If you haven't joined the Starknet, the Telegram channel for the hackathon, please do. I shared. So that one is not the official. There's the official one for support, but this one is the local one. This is just to help track everyone's project and make sure everybody's building something. And also, if maybe you need support from the tutors and all that. Yes. I think that will be all. Do I have anything? And for assignments for Wednesday, last week 3, yes, we've already pushed the one of the participants called my attention to it that the code was not pushed to the GitHub repo. It's now pushed, so you can do your assignment and submit. So all the assignment from week 1 to week 3 will close, the submission form will close next week. Yes, it will close next week so that we can grade. So you have time to also build. So please take your time after the class, try and study. It's very important that you study. Yes, and then start building your project already. There's no time. And before you know it, the deadline is here. All right. Thank you so much, guys, for joining the call. Thank you so much, Manoah, for the session today. So see you guys on Thursday. Same time. Please try as much as possible to come early so that we can start early and end on time. Thank you, guys, and see you on Thursday. Bye. Good night.